All right, here we go. 4 is a new rule. It's the last of the 4 rules. It's the chain rule. Okay. The other ones that we've done already is the power rule. Power rule.
Is the chain rule like
product rule.
Like you chains hang well?
Quotient. No. And this is the chain. Okay. Rule for power. N x to the n minus 1. That's the rule for power, right? You drop them down in front and you subtract 1 from the exponent. Product, what's the rule for product?
Product is
the faster you memorize this, the easier it will be.
Times G plus
F prime G plus
G
prime F. Caden, put that away. What's the rule for quotient?
F prime G minus G prime F over G squared.
I'm stupid.
That's the quotient. So power, product, quotient is a little bit longer. Chain. Here's what chain looks like. Actually, before I give you the formula for chain, let's talk about when you use the chain. So you use the power rule when it's just one straight across. You could just do the main power rule. If it's a product, meaning you're multiplying 2 things together, usually when you have parentheses, that's when you use the product rule. When do you use the quotient rule? Shut it off. Shut it off. When do you use the quotient rule?
When you're dividing.
When you're dividing, when you have a fraction, right? Okay. The chain rule. Here's when you use the chain rule. A chain rule is for something called a composite function, which means a function inside of another function, right? So example of chain rule would be something like, let's say I have x plus 3 squared. Okay, this is a time when you will use the chain rule. Okay? It is a function inside of another function. So the outside function here is this x squared, or is this squared function. The inside function is x plus 3. So basically we've taken this x plus 3 and we've stuck it inside of an x squared. Right? That's what a composite function would look like. All right? Another one would be like the square root of x minus 1. X minus 1 is a function, but it's inside of the square root function. Right? Make sense? Okay, so a function stuck inside of another function. Right? X minus 1 is a function on its own, but it's stuck inside of the square root function. So 2 functions combined. Make sense?
No.
No? You want another example?
Yeah.
Yeah? Let's say we have...
Is this for the chain rule?
That's for chain rule. This is how you know when to use the chain rule.
So, but other,
What's up?
like the product rule, is that just never...
Well, I might do a half of half count.
What?
Like if you're multiplying.
What do you mean?
Like on
I
the
guess I
homework?
don't know about this.
Uh-huh. What about it?
So wait, what are we talking about?
Do you not use the chain rule?
Yeah.
When
What's
it's
the chain rule?
multiplying?
What do you mean when it's multiplying?
Okay, so when you have the
I just wanna make
product
sure I wasn't
function,
missing anything.
the product rule, is there never an exponent on like the outside?
When you're using the product rule?
Mm-hmm.
Okay, so there will come a time, and on your homework assignment, this is the way that I have it set up. I have it set up so that 1 through 4 is just the chain rule only, okay? But the bottom ones on that page, and you have like 5 and 6 are the story problems, 7 and 8 are going to be the chain rule inside of the product rule or the chain rule inside of the quotient rule. So I'll explain to that how you can do one inside of the other, okay? That's going to be the hard part, okay? So for right now, the chain rule you use for a composite function, a function stuck inside of another function. Chain rule, okay? Ready? I'm going to skip to number 3 because this is the most obvious use of the chain rule. So look at number 3. Here we go. Here is how the chain rule works. Ready? So x squared plus 1, this is a function inside of another function, right? Everybody watch. X squared plus 1 is a function inside of another function. So basically the outside function is kind of like x cubed, right? This guy right here is x to the third power, something to the third power, right? Don't write this down yet. Don't write this down yet. How would you find the derivative of x to the third power?
Move the 3 to the front, so it'd be 3x.
This would just be 3x squared, okay? So the chain rule is kind of the same thing as the power rule, except one additional thing on the end of that, okay? So what we're going to do here is the outside function is x to the third power, or something to the third power. We bring this 3 down in front, okay? We leave the inside step when we take it to the second power. We subtract 1. This would be like the 3x squared, right? The inside step is going to stay, except the only difference is when you're doing the chain rule, you have to multiply then by the derivative of the inside, okay?
So x.
So 2x, okay? 2x. So it's just kind of like the power rule in the overall thing. The 3 comes down in front, you subtract 1 from the exponent, you leave the inside, but then you multiply by the derivative of the outside, okay? Here is how I simplify, and here is how I would tell you to simplify. Don't simplify any more than what I'm about to do now. I always take this number that's out in front here, combine it with this guy, and that's all I do to simplify. So 3 and 2x would be 6x on the front, and then I leave the rest of it the same. That's all I do to simplify. And that's all you need to do to simplify. Okay? Makes sense? Good? That's what the chain rule does. So you treat them kind of like the power rule. You leave the inside, but then you take the derivative of the inside at the end.
Wait.
Yeah?
You should do one with a negative.
Okay? This one right here. Okay? So number 1. Go back to number 1 now.
No.
Okay? Turn it off.
Oh, well,
Okay.
technically that's like 1 over x, which is like
So,
x to the half.
well, kind of, okay? So, this technically is a quotient.
Yeah.
Right?
Mm-hmm.
We could use the quotient rule on it if we want to, but doing the chain rule is actually faster. Okay, so take a look at this right here. This guy is like x plus 1 on the bottom, technically to the first power. Okay, so write that in there. That right there means technically x plus 1 to the first power, right? What I'm going to do instead is I'm going to move him to the top, and he will become x plus 1 to the negative first power if I rewrite him. Does that make sense? If I move him to the top, he's x plus 1 to the negative first power. Now I'm going to do the chain rule to that. Okay? So, chain rule says, I'm going to go up here. Chain rule says I bring the negative 1 down in front. I leave the inside. I subtract 1 from the exponent. So negative 2. And then I multiply by the derivative of the inside. What's the derivative of the inside?
1.
Just 1, right?
So you don't write that down.
You really don't have to write the 1 down, but I'm going to just so that we have it, right? Okay, now we got to fix him. So this thing that is to the negative 2 power, I'm going to put him back down in the bottom, right? So to fix him, I'm going to put him back down in the bottom. We have x plus 1 to the positive 2 power now, but what's on the top? Negative 1. If I combine this negative 1 times this 1 on the top, will be the negative 1. Does that make sense? So to do a chain rule, move the bottom step to the top, and then you don't have to do the quotient rule. It's a little bit faster in that case.
Nothing makes sense when you're tired.
What?
I'll say we should just.
Where'd you?
Okay. Where'd I what?
Wait.
Confusing?
No, but you should do one where the exponent on top is negative.
We did. That's what we just did.
No, like 3. Where the to the cubic root or the cubed. No,
What?
What?
the 3 is the negative 3.
That's what we just did right here. This right here. That's exactly what we just did.
Oh.
Right? Isn't that exactly what we did? Right?
I guess.
You still do the same thing. Except when you subtract 1 from the exponent, it's going to be negative 2, but then you move back to the bottom. Same thing. Okay? Good?
Hold up.
All right, ready?
It's a challenge.
Now this one right here. Blah, 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 blah.
So wait.
How'd you get the
Just
1 on the
refresher.
end?
Because you multiply by the derivative of the inside.
The answer's in purple,
Okay.
right?
The overall final simplified version is in the purple. That's the derivative. Okay? All right, we'll do a bunch of these. It'll be okay.
I don't get it.
Are we ready for number 2? Okay, before we take the derivative, we have to rewrite these, right? We have to rewrite these. This bar right here, I can't take the derivative of a bar. It really is like saying 3x squared minus x plus 1 to the 1/2 power, right? That's what the bar means. So I'm going to change him to look like an exponent, and now I'm going to take the derivative. Okay, are we good so far? 1/2 power is square root. Okay, so move the 1/2 down in front. Leave the inside. 3x squared minus x plus 1. And then I subtract 1 from the exponent. If I take 1/2 and subtract 1, what is he now?
Negative 3 or negative 1/2.
Negative 1/2, right? 1/2 minus 1 is negative 1/2. Yeah? Okay, but then what? Times the derivative of the inside. 6x minus 1, right? Okay, now here's how I simplify these. Ready? whenever you do a chain rule that involves something that looks like this, you're usually going to have a top part and a bottom part. Okay, watch this. So I'm going to do my bar here. This is going to be my final answer, and I'm going to write what goes on the top and what goes on the bottom. Okay? So,
2 goes on the bottom.
2 goes on the bottom, right? You see this 2 right here? He's going to go on the bottom. Okay? This 1 goes on the top with, what else?
The x, 6x.
6x minus 1, right?
Yeah.
So that's just 6x minus 1, because if I take it times 1, it's just 6x minus 1, right?
And then the
Okay.
3x
Then the negative 1/2 power, that's going to go to the bottom also. But
it becomes a positive.
it becomes a positive 1/2, which is going to change back to a square root. Does that make sense? So do your bar and put where everything goes. Like the top part goes on the top. If you have a fraction in the bottom, the 2 will go in the bottom plus the square root stuff. Okay, good?
Yeah.
All right? This is going to feel a little bit foreign to you for a little bit, but that's okay. The more we do this, the easier it will be. Okay? Good? Woo. That's what the derivative is. Don't simplify any more than that. Okay? Good? Yeah?
What?
All right, moving on.
No, the math.
Next piece down here at the bottom.
The math is
Oh, what was the answer to number 3? That. Yep. Okay. Good, good. All right, I'm just going to do the next example. Don't worry about the u part so much. You can cross the u out. We're just going to find the derivative of him, okay? So this one's going to be very similar to number 3 up above. So
Wait.
first step.
Go back to 3.
Oh my god.
I don't know why I don't.
Okay, so you can cross out the u part down below because, I'm not going to have you guys learn it that way. Okay, I want to take the derivative of this guy. So what happens first?
No.
What happens first?
3 goes to the front.
3 goes to the front. This guy goes to the front. Okay, leave the inside. 3x minus 2x squared, that stays. The new exponent is
1. Wait.
2.
2.
Holy shit, you're stupid.
No, I was thinking of
Warning.
the inside.
Warning. 2 is your new exponent, but am I done?
Yeah.
No.
Last thing,
You
multiply
need
by
It'll be negative 4x.
By the derivative of the
minus
inside.
the derivative of the inside.
Is
Plus 1.
2. Oh wait.
Negative.
You want to put it in order or not?
Yeah.
Put in order, yes.
Negative 4x plus 3, because these two need to switch places with each other. So negative 4x plus 3. Okay, now,
No, the derivative of. Oh, never mind.
derivative of the inside.
Man, you suck.
Derivative of the inside.
And
Okay.
then you multiply the negative.
This guy, multiply him with this guy. So, negative
12
12x plus
9.
9, and leave him in parentheses.
3x minus 2x squared.
3x minus 2x squared
I'll see you in college.
squared. Okay, we're just rearranging him, and this is my simplification.
Wow.
Good? Happy with that?
I'm good in class.
Okay, now, do you understand why you use the chain rule on this? It's a function stuck inside of another function, like he's stuck inside of the cube, right? This is a chain. All right, good? Okay, next
Yes.
thing. Find all points on the graph of this function for which f prime of x equals 0. What is f prime of x? What does that mean? So we're trying to find where the derivative equals 0. Okay, so we first need to find the derivative and set him equal to 0. Okay, we want to find the derivative of this thing. Ugh. All right, we've got x squared minus 1 squared stuck inside of the cubic root. But what does the cubic root actually mean?
To that
2/3.
third. Yeah.
He's to the 1/3 power, but since there's a 2 already there, he will be to the 2/3 power. Does that make sense? You get rid of the radical before you take the square, or before you do the chain rule. Okay, so he's going to be to the 2/3 power. Make sense?
Mm-hmm.
Good?
I'm not
Okay,
a fan of
I'm going to
this.
do the chain. Now I'm taking the derivative. So, first thing,
Move to the front.
2/3 comes down in front. Leave the middle. What's 2/3 minus 1?
Negative 1/3.
Negative 1/3. And then you
And you multiply by x.
multiply by 2x. because that's the derivative in the inside. X squared minus 1 is 2x, yeah?
2/3
Okay,
times 2.
so we want to put the top stuff and the bottom stuff. What goes on the top?
4x.
2 and this 2x, right? Those are top pieces. So 4x goes on the top. Okay, on the bottom, we have this 3,
3 cubic roots
and we want the cubic root of
x squared minus 1.
that junk. Does that make sense? Yeah?
What if I just did forward? No, never mind.
Okay, good. You could write this a little bit different, but I think this may be the easiest way to write it. Okay, that's my derivative. Now what do we want to do with that?
Now plug 0 in.
No, we're not plugging 0 in. You're setting the derivative equal to 0. Equal to 0, and I want to solve for x.
Oh my
Now, whoa, just wait.
It's gonna be 0.
This is going to be really nice. How do I solve for x? What are you going to do
Multiply
first?
the bottom over.
Multiply the bottom over. So 3 cubic roots of we don't really care, because what's going to happen when you multiply it over?
4x equals 0. Divide by 4. X equals 0.
When you multiply them to the other side,
Cross out.
4x is going to be equal to 0 times that thing is just 0, right? And then,
Plug in 0.
Divide
nope,
by 4.
then you're dividing by 4. So x is equal to whatever 0 divided by 4 is, which is
0.
0. So we have solved. We have found where the derivative is 0. Okay, in chapter 5 we'll talk more about the significance of that, the derivative being 0. You might already be able to figure it out, what it means, but anyway. The slope of the tangent line is 0, so you have a horizontal tangent line. So what occurs at that point?
It's a vertice.
Either a high point or a low point. So we talk more about that in chapter 5. Okay? Good? Ugh, I ran down in the wrong spot. Here we go. Finding derivatives. Simplifying derivatives. Okay? This is going to be problems 7 and 8. Okay? These ones are a touch harder than normal. Touch harder than normal. Okay? I ran out of room here. Can I do, like, let's do number 1 over here. I'm going to do 1 down here at the bottom. Okay? F of x equals, okay? Choosing where you start is probably the hardest part. So we have to identify what rule we are using or what is happening to this function. Okay, I have 2 pieces here. I have x squared and I have this guy. And what's happening to them?
No, this power.
You are, no, it's not power. You are multiplying those 2 things together. So that means we have a product, right? We are doing a product, okay? So here's the deal. Product is f prime g plus g prime f, right? F prime g plus g prime f. What is f in this case?
X squared.
X squared is my f. G is going to be this guy, okay? So we're just gonna do the pieces. F prime g plus g prime f. I've got those 4 pieces, okay? What's f prime going to be? 2x. G stays. 1 minus x squared. Now, here's where the chain rule comes in. How do you find the derivative of the square root of 1 minus x squared?
Oh my god.
The chain rule. So, what this is right here, this guy is a chain inside of what? Product. Okay?